Hello everyone and welcome to WAN Tech Corner. In this video, I will install official OpenWrt 25 on the Banana Pi BPI-R4 and check out its performance. To take it easy, I will run the latest firmware and flashes on the micro SD card with root first. For this test, I use the XFP Plus ports. The router's XFP LAN ports is connected to my PC via the MLO Connect X3, and the XFP Plus 1 port is connected to the upstream server via the 10 gigabit switch. Let's insert the micro SD card, connect the power cable, and turn it on. This is the LuCI page at 192.168.1.1. OpenWrt 25 come with the new firmware check features, and I will turn it off. As always, let's set up a root passwords before proceeding. For this test, I changed the WAN interface to XFP1 and the XFP LAN remains in the BR-LAN bridge. Packet steering is enabled for all CPU with 128 steering flows. Shortwave offloading is disabled by default. To see the CPU uses, I have BTOP running on the console. Let's start the iPub3 test. With 4 streams running in normal direction or offload, the throughput is roughly 3.48 gigabit per second. During the test, only core 0s is having high load. Changing the number of streams to 16, we can see a high drop in the throughput. It is now 2.74 gigabit per second. We can clearly see that only core 0s is fully loaded, where all the cores are just at 10 or 15%. I will change the LAN interface to XFP LAN only, and let's see if it makes any differences. Well, we can see that the throughput remains very slow, at just 2.5 to 2.75 gigabit per second. In my previous video, with the stock firmware, the BPI-R4 can support up to 9.16 gigabit per second WAN-to-LAN throughput. It looks like something is wrong with either the CPU packet steering or the firmware itself. I will investigate this further. Now let's take a look at wireless performance. I have the BPI-R4-NIC-BE14 installed on the board and it's working fine with the stock firmware. For this test, I used the Intel BE200 card with the latest driver version 24.40.0.4. The distance between the AP or the BPI-R4 and my PC is just 1 meter and it is in a visual line. Testing with OpenWrt 25.12.4, MediaTek MT7960E is recognized with 3 radios. I tried to set up SSID in BE mode, AX and AC mode, but it will fail to start. As you can see, I changed from WPA3 to WPA2 using very basic channels with 1, 36, 64, but the SSID is always in disabled state. The maximum transmit power is 7 dBm. The same problem happens on other radio as well. And we can see that the transmit power stays 0 dBm. According to OpenWrt product page, there are some problems with the TX power of the BE14 and workaround is available by adding device tree overlay to the config. More information is available on the issue reported by EF1F and PR2MT76 branch from IM0 or PR from down Parlic to add the overlay, which already merged. Here, I will create a file with vEditor, copy and paste the content, chmod and run it. After a reboot, the TX power is back to normal and the wireless is functional. To make it short, I will skip the wireless configuration part and we will jump right into the speed test section. First, let's start the wireless test with Wi-Fi 7 or BE mode channel 37, 6.135 GHz and 160 MHz channel width. Transmit powers E23 DPM. Country code Vietnam. Here, wireless security is WPA3 SAE and other parameters leave at default. On my Windows 11 PC, the reported link speed is 2882 Mbps. Running a WAN-to-LAN open speed test, the download speed is up to 1782 Mbps. The same speed can be seen from the Task Manager Wi-Fi throughput. The upload speed is a little bit higher, 1849 Mbps. The same speed is recorded in the second attempt. I also give a try with iPub3. Interestingly, the throughput with a stream is just 1.6 gigabit per second, much more slower compared to Speedtest. I change the bandwidth to 320 MHz and leave all the parameters unchanged. Taking a look at the Wi-Fi interface connection, the link speed is 5.1 gigabit/3.6 gigabit per second. I assume it is 5.1 gigabit downlink and 3.6 gigabit uplink. Anyway, let's give it a try. The speed is surprisingly slow. It's just half the speed I got with 160 MHz. The test completed with 774 Mbps download and 897 Mbps upload. iPub3 throughput with 4 streams in normal directions is 674 Mbps and 840 Mbps when changing the streams to 16. Now, let's check out 2.4 GHz Wi-Fi 7 throughput. This is the wireless settings, BE mode, 2.4 GHz band, channel 6, and 40 MHz channel width. The maximum transmit power is at 23 dBm. On Windows 11, the reported link speed is 325 for receive and 292 Mbps for transmit. I noted that the number is fluctuating every time I check the status. This should be due to the 2.4 GHz frequencies is heavily congested. I have run the open speed test several times and the download speed is 205 Mbps, where the upload speed is around 125 Mbps. Let's find out the Wi-Fi 7 throughput on 5 GHz. This is the current AP configuration. BE mode, 5 GHz, channel 60, 500 and 3000 MHz or 5.3 GHz. Channel width 160 MHz. Transmit power is set to 23 dPm, but it says the current power is just 20 dPm. I think there's no need to investigate this further and we can just proceed with the speed test. I run the open speed test several times and the recorded speed is 1600 Mbps for download and 1700 Mbps for upload. We can see that the speed is just 100 or 150 Mbps lower compared to the Wi-Fi 7 throughput on 6 GHz. I also changed the bandwidth to 320 MHz. Unfortunately, after making the change, the address ID is no longer visible to my PC. Perhaps 320 MHz is not available in my country due to DFS. Lastly, I will give a try with multi-link operation or MLO configuration. This feature is quite new and only available in OpenWrt 25 release. From the information on the OpenWrt forum and GitHub, there seem to be a lot of bugs with MLO, but let's give it a try. In the first attempt, I set up MLO between 5 GHz 160 MHz bandwidth and 6 GHz 320 MHz bandwidth. The SSID is broadcasting, however, I can only connect to it via 5 GHz. IWAP-MLD0 reported that there is only one MLD link, which is the 5 GHz radio. So I changed the bandwidth of the 6 GHz interface to 160 MHz and it started to work. Here, we can see that the MLD with links section reports two link ID, one on channel 44, 5 GHz, and the other one on channel 37, 6 GHz. Windows 11 reports that we are connected to the SSID via two channels, 6 GHz on channel 37 and 5 GHz on channel 44. The aggregated link speed is 2882 Mbps. This is great. Testing with Speedtest, the average download speed is 1.8 gigabit per second and the upload speed is up to 2 gigabit per second. PUB3 throughput is a little bit slower. With 16 streams in normal direction, the throughput is 1.87 gigabit per second. Running the test in reverse with 16 streams, the throughput is 1.5 gigabit per second. I have also noted a strange behavior when connected to the Wi-Fi MLO SSID. After 10 or 15 minutes, the connection is down and I was unable to ping the gateway, which is 192.168.1.1. I have to disable and re-enable Wi-Fi to get the connection up and running again. Perhaps something is wrong with either the firmware or the configurations of the BPI-R4 or the Intel wireless driver itself. I will continue to investigate this further. Alright, so that will be all for this video. I will put my config on the website so that you can give a try with your device. If you have any idea to improve the throughput, please leave it in the comment section. I will be happy to give it a try. Thanks for watching and see you all in the next video.